Hi everybody, welcome to another video in Business Calculus section 10.3 derivatives of products and quotients. So pretty much we will have product rule and quotient rule in this section. Very straightforward. First, product rule theorem. If we have a function as a product of the first terms times the second first function times the second function, and the derivative of those functions exists, then the derivative of the product is given in that form. By the way, we prefer to write in this form. So derivative of u times v is derivative of u times v plus u times derivative of v. So just uv and uv derivative on the outside, but in general, if I write three terms, you will get the idea of the product rule in general. If I have three terms, u, v, w, and I want to find the product of three terms like that, find the derivative of the product of three terms like that, then there are three of them. I will have three of them. Right. And then derivative on the first, derivative on the second, derivative on the third. So that's how the product rule work in general. You will see the pattern. If there are four terms, four function times together, there will be four of them, each one at the product of four, and derivative will jump from the first to the second to the third, and then so on. So that's the product rule, how the product rule works. Right, and look at a couple of samples. Right. So here we will find the derivative of this with or and without the product rule. So first, let's do that without the product rule. So I will write the function right, 2x squared times x cubed be 2x to the fifth, 2x squared minus 2 will be minus 4x squared plus x cubed minus 2. And so taking derivative just using the power rule, that gives us x to the fifth, so 5x to the fourth power minus 4 times 2x plus 3x squared. Derivative of negative 2, that constant will be 0. So we have 10x to the fourth minus 8x plus 3x squared. Of course, you can put them in decreasing order. So 10x to the fourth plus 3x squared minus ax. So that is without the product rule. This one we just multiply it out. That's easy. Now let's use the product rule. Product rule, this is clearly a product. So let's this be u and the other one is v. U equal to 2x squared plus 1 and v x cubed minus 2. Well, u prime, derivative of that will be 2 times 2x will be 4x, and derivative of v derivative x cubed 3x squared. Right. Now let's find derivative of y, which is derivative of the product. And the product rule says u prime v plus u v prime. Right, just put everything in here. U prime for x, v x cubed minus 2 plus u v prime is 3x squared. Now multiply. So of course we can multiply it out and simplify. We should expect to have the same things here. Alright, let's do that. So this gives us 4x to the 4th power minus ax, and that gives us 6x to the 4th power plus 3x squared, and combine like terms for 4x to the 4th, 6x to the 4th, make it 10 plus 3x squared minus ax. Of course that should be the same. So this of course that's not a proof, it just demonstrate how the product rule would work. And of course we check the answer without the product rule. Alright, now if it is simple like this, we can just go without the product rule, because something like this we multiply it out anyway when we do the product rule. So can just use that. There are plenty of examples that we have to use the product rule. Right. Now let's go to this example. We have the function. Find the equation of tangent line to the graph at the point. So recall the equation of the tangent line. Y minus 2 the values of the function equal to the derivative x minus a. So the equation of the tangent line to the graph, equation of tangent line to the graph at a is given by this. Right, so in this case a is going to be 3. So we have the function, now we have the derivative, and then we just put in the formula. That should be easy, right? So the function to x minus 9 x squared plus 5, right? Multiply them out. So I will use find the derivative without the product rule here, right? So 2x cubed plus 10x minus 9x squared minus 45. So just put them in decreasing order. Now we take derivative. Be 2 times 3 will be 6 x squared, 9 times 2x 18x plus 10. Right, so we have the function, we have the derivative. We have the point at 3, so we will evaluate at x equal to 3 the function at 3. I'm going to put 3 in here. Right, if we have a calculator, just do this. Take 3, store into x. So 3 equal to x, and then we evaluate this function. 2x cubed minus 9x squared plus 10x minus 45 give us negative 42. Of course, we can use the original function as well. 2x minus 9 x squared plus 5. Yeah. And now we test, we put 3 into the derivative. Which is, this is the derivative, 6 3 squared minus 18 times 3 plus 10. Or I just say 6, I store 3 into x already, so this should still be the same. 6x squared minus 18x plus 10. That would be 10. Right. Just want to show you this quickly. So this calculator can find derivative at a point. So if we want to, we can do this. Math, option number 8. So we find the derivative with respect to x. So this is the notation for derivative, d over dx. And then the function, I'm going to put the original to x minus 9 x squared plus 5. Right? So we take the derivative of the function when x equal to 3. Remember, the calculator will not find the derivative for you, but it will calculate the derivative at a point. And we have 10. Of course, there's some error there, but still 10. So that's why we don't use calculator to do this. To check the derivative, we just confirm it. Because the answer is not going to be exact. There's some calculation error there. Right. Now with that, we can put the values of the function is negative 42, and the derivative is 10, and a of course is 3. So we have y minus 40 negative 42 equal to 10 x minus 3. So y plus 42 equal to 10x minus 30, and move the 42 on the other side, y equal to 10x minus 42 minus 72. Right, so that's what we have. Equation of tangent line is that. Right. So on that previous problem, we did not use the product rule, we just multiply it out. And I would advise you, if you can multiply it out, just do that. There's some certain problem that we have to use the product rule, namely something like this, because we cannot simplify this any further. So we say have a product. So we say u is 2x cubed and v is e to the x. Right, derivative of u is going to be 2 times 2x squared, so 2 times 2 is 6 x squared. V, derivative of e to the x is e to the x. Right, now it's a good place to review some basic derivative. Derivative of e to the x is the same thing. The power rule is we did a lot of power rule, so I'm not going to write out the power rule. Derivative of some other base, we need to times that ln of the base. And now let's look at the derivative of ln of x is 1 over x, and derivative of other base of x 1 over ln of a times x. Sorry, kind of run out of space, but that's what we have. Right. Now we check the derivative. I'm just going to write out the product rule, because the function now is the product of u and v, and now we take the derivative of the product, which is the product rule. u prime 6x squared times v e to the x plus u to x cubed v prime e to the x. So we have 6x squared times e to the x plus 2x cubed times e to the x. If we want to, we can factor out e to the x. Actually, you can also factor out x squared and 2 as well, but I just factored out e to the x. I have 6x squared plus 2x cubed. Right, straightforward. Product rule, just write down what is u, what is v, take derivative, and then the product rule, pretty much. Now we also have a product here. That is u, and this is v. So we write out what is u and what is v. So u is 6x to the 4th. V is ln of x. U prime 6 times 4x cubed. So 24 x cubed. V prime derivative ln of x is 1 over x. Right, so we have the derivative of the product. Right, u prime 24x cubed v ln of x plus u 6x to the 4th v 1 over x. Right, so we have 24 x cubed ln of x plus 64 x to the 4th cancel, put x, cancel 1x here, we have 3 left, 64 x cubed. Of course, if you want to, you can factor out x cubed, but we don't have to. You can just leave the answer in that form, on this form, doesn't matter. Right, now we have a product here. So u is 2 to the x and v is log by 3 of x. So we take derivative of 2 to the x. This is not power rule, this is exponential rule. We have e to the x. If it is something other than e, we have to times ln of the base. So in this case we have ln of 2 and then 2 to the x, and v prime is 1 over ln of the base times x. Right, and then the product rule. U prime ln of 2 to the x times log by 3 of x plus u 2 to the x times v prime we cannot simplify anything in that form, so just going to leave it like that. But that is the product rule. Right, next we have derivative of a quotient, or quotient rule, pretty much. So if we have the function have the top and the bottom, and derivative of the top and the bottom is this, then derivative of the quotient is given by this, or I will write using u and v. So again, u prime v minus u v prime, and then over v squared. So that's the quotient rule. Right now we cannot prove the quotient rule, but when we go to the next section we can prove the quotient rule, but again a bit more complicated, but that's just a rule and we stick to it, should be fine. Right, look at the first example here. Right, let's use the product rule. By the way, on a big scheme of things, just like we talk about the product rule, sometimes we don't have to use it. And this is another example that we may or may not. We can do the problem with and without product rule. So for that first example, I will do both with and without product rule. I mean quotient rule. So let's say without quotient rule. So in that case, just simplify the function first. Okay. So there's a couple ways to simplify. First, I can split like that, and then when we divide we subtract the exponent. 5 minus 3 is 2, and then 2t squared, t squared and t cubed cancel, or we just divide, subtract the exponent. 2 minus 3 is 1 minus 1, right? Or we can just do it like this, t to the 5th minus 2t squared. We have t cubed at the bottom, which we move to the top, it becomes negative t to negative 3, and now we multiply it out. 5, when we multiply this time we add the exponent. 5 plus negative 3 is 2, and 2 plus negative 3 is negative 1. Either way we have that, so derivative will be easy, just power rule here. 2t squared, t squared derivative is 2t, and derivative of this is negative 2. Take out the negative 1, original power minus 1. So we have 2t plus 2t to negative 2. Right. So that is the derivative without the quotient rule. Now let's use the quotient rule. For that we need u and v. T to the 5th minus 2t squared, and v is t cubed. So u prime is 5 t to the 4th minus 4t, and v prime is 3t squared. Right, show the quotient rule. U prime v minus uv prime over v squared. U prime 5t to the 4th minus 4t times v, u prime v minus u v prime over v squared. So that gives us 5 t to the 7 minus 4 t to the 4th 3t squared times that gives 3, but minus 3t to the 7. That gives us 3t to the 7 with the minus, and then minus that plus 2, that's 6 t to the 4th over t cube square. 3 times 2 is 6. Right, to simplify this, we have 5 minus 3, that's 2t to the 7 plus 2t to the 6 2 to the 4, sorry, over t to the 6. We can split them out. So that gives us 2t, subtract the exponent 7 minus 6, and then subtract the exponent 4 minus 6 is negative 2. Right, should get the same thing with or without the quotient rule. By the way, depends on what form we want. Sometimes there's advantage to stop the problem at this step, and sometimes there's advantage to stop the problem at this step. I'm just going to work this out so we show that they are the same. So in this one we can use the quotient rule or not, it doesn't really matter. Of course I prefer this way because the power rule is the most fundamental, and I want to, if we can stuck with that, that will be easier. Right, now on this one we have to use the quotient rule. So what make it, this one we can use a quotient rule, and this one we cannot. Right, the problem is this one we have t cubed at the bottom. We can always split the top, we can never split the bottom. So x squared plus 5 at the bottom, so it's just x squared plus 5 at the bottom. We cannot really do anything. So this one have to use the quotient rule, because we cannot just split the term and cancel out like we do here. We can split as x cubed over x squared plus 5, and then minus x over x squared plus 5. We cannot simplify anything here. So no quotient rule here because we cannot split the bottom to cancel out with what we have on the top. Alright, so quotient rule. Let u be the top, x cubed minus x, and v x squared plus 5. We take derivative. That gives us 3x squared minus 1, and derivative here is 2x. Right, so derivative of the quotient. Of course, it's quotient rule. U prime v minus u v prime over v squared. Right, so that gives us 3x to the 4th plus 15 x squared minus x squared minus 5 minus 2x to the 4th, 2x to the 4th with a minus, and then 2x that minus 2x square minus that the plus. So be mindful with this negative sign in the quotient rule. So minus 2x with a minus, make it plus 2x squared. Right at the bottom, x squared plus 5. Usually we never multiply now the denominator, so we're just going to keep it like this. There's some advantage of doing that. So I'll combine like terms. 3 minus 2, that's x to the 4th. 15 and 2 make it 17. Sorry. 15 and 2 but minus 1, that's 16. 14, that's 16. X squared, and then there's the minus 5 by itself, over x squared plus 5 at the bottom, square. So we just like that. Right, now we have this. Again, u is the top, negative 3e to the x. V is 1 plus e to the x. Again, this one we have to use the quotient rule because we cannot simplify this. Derivative of e to the x is the same thing. Derivative of 1 constant, derivative is going to be 0. We just have e to the x for that. So we have derivative of a quotient alright, u prime v minus u v prime over v squared. Right, so multiply it out. Negative 3 e to the x, negative 3 e to the x times e to the x, on the same basis. We just add the exponent x plus x, which is 2x. Right, I'll just write it out. So we have e to the x times e to the x is e to the x plus x, e to the 2x. Yeah, that's what we have here. Minus a negative, that plus 3 e to the 2x over 1 plus e to the x squared. Right? Can we simplify anything? Well, that. Right? Oh, simple enough. Okay, so u prime, v prime, and just once again be mindful with that negative sign. Right, more samples. Okay, so once again there's a quotient, so we use quotient rule. U is ln of x, v is 2x plus 5, u prime is 1 over x, v prime 2. Right, now we can check the derivative. U prime v minus uv prime over v squared. u prime v minus u v prime over v square right. Can we really simplify anything here? By the way, we can just leave the answer like that. That was the derivative. The only problem that I don't like is then an x, a fraction inside a fraction. That look complicated. So in that case, what I will do, what if we multiply x top and bottom? So in that case, this x cancel with this x, and we just have 2x plus 5. But then again, we do multiply x to this term as well. So ln of x times 2x. Over 2x square, 2x plus 5 square, sorry. Times x. So that gives us 2x plus 5 minus 2x ln of x over x times 2x plus 5 square. Right, next we have this. Alright, so like we have the product on the top, and then the altogether is the quotient. So we do need to multiply it out. So I just simplified it. I just want to simplify so we don't have to have the product rule and the quotient rule. 2x times x, 2x square, 2x times 3, that's 6x, minus x minus 3. At the bottom, 5x minus 1. I simplify this. 2x square plus 5x minus 3 over 5x minus 1. So that's what we have. Right, now we use the quotient rule. U equal to 2x square plus 5x minus 3. V is 5x minus 1. U prime is 4x plus 5, and v prime is 5. Now we take the derivative of a quotient. So quotient rule u prime v minus u v prime over v square. Right, multiply them out. 20x square minus 4x plus 25x minus 5 minus 5, that's 10 x square 25x. But as with the minus, like I said, be mindful with that negative. Negative 2 times 5 is negative 15, but an extra negative, like a plus, over 5x minus 1 square. So we just need to simplify, combine like terms, 20 and 10, that's 10x square. And how many x we have? Well, that conveniently cancel out. Just minus 4x. and 15 and 10, 15 and minus 5, at plus 10 over 5x minus 1 square. So that's what we have. Right, next we have the total sales, and we have an application problem. The total sales in thousands of games, video games, after T month when it is released is given by this. Now find the derivative. Well, this is simple, straightforward. We use the quotient rule because the top is fine, but the bottom, we cannot split the bottom. So derivative of that, take out the 2, that will be 250 t v prime will be 2t. So derivative of t equal to quotient rule. U prime v minus u v prime over v square. So we have u prime minus v minus u v prime over v square. So multiply that, give us 250 t cubed plus 25,000, there 3 zeros, t, and then minus that 250 t cubed over t square plus 100 square, right? So conveniently cancel out, so we have 25,000 t over t square 100 square. Right. So that is the derivative. Now we just evaluate at 10 and evaluate the function at 10. So first we store 10 into x or t, doesn't matter. I use x. Right. And then the function, let's do the derivative at 10. So I'm just going to type that in. Yeah, we can just type 25,000 t or x divided by the bottom. Just put extra pair parentheses, which is divide. Extra pair parentheses x square plus 100. $6.25. Now, there's another way to do this. Just take the derivative of this function, math. Go to option number 8. Numerically find derivative. Right time, enter the function. If you want the fraction, hit alpha, alpha, zoom. Where the fraction? Alpha y equal, alpha y equal, that's the first one. 125 x square over x square plus 100. Evaluate when x equal to 10. This is in thousands of games, so when we have 10, that means 10,000 games. We should get the same thing. That's cool. Right. Now we evaluate the function at 10. We have 10 equal to x already. Now we just enter the function, which is this. Alpha y equal to, we have a fraction, 125 x squared. We still have x equal to 10. We haven't changed that values. X squared plus 100. So that is the original function. At x equal to 10, we have 125 over 2. If you want the fraction, if you want the decimal, hit math. Fraction is number 1, decimal is number 2. 62.5. Right. Now next, estimate 11. Now this is like the marginal analysis we did way back on the previous chapter. Let's write out what do we have. Alright, so derivative in general using definition now. If we say t is equal to 10 and let h equal to 1, so we can say derivative at 10 approximately. So now if we let h equal to 1, it will no longer equal to, it's approximately equal to. Now remember, t is 10 and h is 1. H is 1, so that's just divide by 1. So derivative at 10 equal to derivative at 10 approximately equal to s of 11 minus s of 10. So we solve for s of 11 approximately equal to s prime of 10 plus s of 10. S prime of 10 is 6.25 is the derivative, and the function at 10 is 62.5. So pretty much we just said we have this values plus that value. When we highlight, we hit enter, like copy and paste. 68.75. Of course I can do that by hand too, but just want to demonstrate that. Right, so that's an application using the quotient rule. So with that, we stop section 10.3 here. As always, thank you for watching and see you in another video in business calculus.